When we multiply with the same base, the rule is that we add the exponents. The thinking behind that is that if I have something like x squared times x to the third, that's the same as saying x times x, that would be x squared, times x times x times x, that would be x cubed. Notice that gives us 5 x's multiplying each other, so x to the fifth. The shortcut says we can skip this middle step, but instead see this as x to the 2 plus 3, and that means that we have x to the fifth. We can even do this when we have more complex examples like the second one. First, I would regroup, so the x's are together and the y's are together. So this is x to the third times x, if we want to think about this as x to the first, times y squared times y to the negative fifth, because the commutative property of multiplication tells us we can change the order of multiplication. So x to the 3 plus 1 times y to the 2 plus negative 5 would be the same as x to the fourth times y to the negative third. But when we simplify a problem like this, we're not allowed to leave negative exponents in our answer. So that means we have to remember from lesson 1 that y to the negative third is the same as 1 over y to the third. When we multiply those two together, we get x to the fourth over y to the third. For the last problem, again, we can regroup. I can multiply numbers by numbers and variables by variables. We know that 4 times negative 3 is negative 12, and that x to the fourth times x to the seventh is x to the 4 plus 7. Simplifying, we see that this is equal to negative 12 x to the 11th. The next rule for multiplying is called the power to a power rule. It says that when you raise a power to a power, you're essentially multiplying the powers together, and we can think about why that is. If I have x squared and then I'm raising that to the third power, that's like saying x squared times x squared times x squared, because we know that raising something to the third power is the same as multiplying it by itself 3 times. If we use the rule we learned above, that would be x to the 2 plus 2 plus 2, or x to the 6th. But notice 6 is the product of 2 and 3, which is where this shortcut or this law of exponents comes from. So when we go to do the problem, we say this is x to the 2 times 3, or x to the 6th, and it's significantly shorter than having to write the whole thing out. Doing the next problem and following the rule, we're going to multiply these powers because we're raising a power to a power. So this is x to the 3 times negative 6, which is equal to x to the negative 18th. But just like we saw in the middle problem above, we can't leave a negative exponent in our final answer, so we must remember to take the reciprocal. Remembering that when we do take the reciprocal, the power is no longer negative. In the last example in this set, we want to remember that the power only applies to the things in parentheses. It does not apply to anything outside of parentheses. So the 6 is still a 6. But the x is going to be to the power of 5 times 4. So our final answer is 6x to the 20th. Our final multiplication rule for exponents is going to be a product to a power. This says the product of xy raised to the power of a is the same as raising x to the power of a and then raising y to the power of a. So basically, if we were to think about this first example, if we were to do it the long way, we would say this is xy times xy times xy. That's what it would mean to cube it. We could then regroup and say this is x times x times x times y times y times y, and we can see that that's x cubed, y cubed. That would get us to our final answer using the rules we already know. But the short way is to use this rule, which says I simply take x and cube it and y and cube it, because this cube applies to everything inside the parentheses. So that becomes the shortcut. Let's use the shortcut as we do the rest of the problems. If I have x squared y to the negative third, and I'm raising the whole thing to the power of negative 1, that means I can use the power to a power rule to say this is x to the 2 times negative 1 times y to the negative 3 times negative 1. So I'm using a combination of these second two rules. When I raise a power to a power, I multiply the powers. And if I have two things that were already multiplying each other and I want to raise the whole thing to a power, I can raise each part to the power individually. So this becomes x to the negative second times y to the positive third. And just as we've done with other problems, we know that we can't leave a negative exponent in our answer. When we take the reciprocal of x to the negative second, the y to the third will remain on the top because it doesn't have a negative power, but the x squared will move to the denominator to be its reciprocal. In the third example, we have one situation where there is a product to a power. So only the things inside the parentheses need to be raised to the fourth power. This x squared simply hangs out. So I have x squared times x to the fourth times y to the negative third times 4. Well, with the x's, we can use the original law of exponents we looked at earlier today and say this is x to the 2 plus 4, or x to the 6th. We're going to use our power to a power rule and say this is y to the negative 12th. But that's a negative exponent, so we know it needs to go to the denominator. So our final answer becomes x to the 6th divided by y to the 12th. Finally, we have a couple of examples using scientific notation. These rules really aren't any different than anything else. We just need to be careful, and we'll probably want a calculator. We can regroup these problems just like we can regroup the problems that have variables. So I can think of this as being 2.1 times 1.56. And using my calculator, I can see that that comes out to be 3.276. And then I can multiply the powers of 10. 10 to the third times 10 to the fourth is 10 to the 3 plus a negative 4. Because essentially we are multiplying with the same base, so we add the exponents. Well, that leaves us with 3.276 times 10 to the negative first. And this is the only situation we're allowed to leave a negative exponent. Scientific notation is intended to allow both positive and negative exponents in the answer. The second example for scientific notation includes this product to a power. So we need to realize that 3.25 is being raised to the power of negative 3, and 10 to the fifth, 10 to the fifth is also being raised to the power of negative 3. Unfortunately, my pen has stopped writing, so I'm going to have to talk you through it, and then I'll type out the steps. So we're taking 3.25 to the power of negative 3, and then 10 to the fifth to the power of negative 3. So we know that we'll have to multiply those powers together. When we multiply those together, we see that we have 10 to the negative 15th. When we raise a 3.25 to the negative third power in a calculator, we get approximately 0.029. The 10 to the fifth to the negative third was 10 to the negative 15th. The only problem with what we have right now is that this is not in scientific notation because we don't have 1 point behind the decimal. We're going to need to move the decimal 2 places to get it to be between the 2 and the 9. Since that's going to make this first number bigger, our powers are going to have to get a little bit smaller.